This video is made to go over the notes that we took on page 2 in class, just in case you missed it or need to revisit it. So, labs are going to require us to work with lots of chemicals, and some of them are going to be dangerous and some aren't. And everyone is always asking me, can I touch it? Is it going to hurt? Is it going to kill me? Is it going to hurt while it kills me? And the best place to find that information is honestly online. A lot of this stuff I would have to look up myself. But you can't just Google, is blah blah safe? Because you're probably going to get 10,000 results and all of them are going to disagree, or at least generally say like yes, no, and then someone maybe, or you could get away with it and it probably won't kill you. So we need reliable information in order to figure out whether something is safe. And the best place to look for that, best way to find reliable information is to use a chemical SDS, or the label on the bottle. But a chemical SDS stands for Chemical Safety Data Sheet, and those communicate detailed safety and handling information about chemical products. And they've been standardized to include all of this important information. All 16 sections that you see here will be in every single SDS. And every company that produces, ships, distributes any kind of chemicals are required to have or manufacture an SDS for that chemical. So you can just type in Windex SDS. If your cat happened to accidentally drink some Windex, you can figure out what to do. First aid measures, just if it's hazardous or not, and what to do about it. You can Google like hydrochloric acid SDS, and you'll probably get a lot of different results because a lot of people make and distribute it. Those 3 little letters, SDS, is the key to you finding this reliable information, generally 1 or 2 pages, so it's quick to skim through. You don't have to read through 10 different paragraphs about how somebody's mom hurt themselves with it, but how if you do this, then it'll be safe. It's all just the facts that you need. So, very useful place to get information, and I have had students use that before when they're not at school, especially in order to get information about something they've been exposed to and quickly figure out, is this worth telling my parents about? Is this something I might need to go to the hospital for? Or is this something I can handle myself? Now, you should always involve your parents in any kind of safety situation, but at least if you get some information first, then maybe you won't freak them out too much about something that might have happened. Now, we don't always have time to go and search up an SDS and read through a couple of pages of information, especially if something has already happened. We want to know what's dangerous, what's not, real quick, instantly, in fact. Now, not every single substance will have one of these on it, but oftentimes the labels for our chemicals that we buy from chemical suppliers will have these NFPA diamonds. And they're not just on chemical bottles. You might see these on trucks driving down the road, or on chemical storage kind of warehouses, or even just like the propane tank kind of enclosures that they have at gas stations or at stores. They all are required to have this NFPA diamond on there in order to relate those hazards in a quick, efficient way. Where you don't have to go Google what the danger is. You can glance at this diamond, see these different colors, and there'll be numbers in the different colored spaces to tell us how big of a risk there is of that type of hazard. So, to fill in some blanks here, the red, blue, and yellow squares in this diamond indicate the degree of risk for several different types of hazards. So there's a specific type of risk that we associate with this blue square, and there's going to be a number from 0 to 4 in that blue square, and that will tell us how dangerous, how much risk there is of that specific blue risk in that specific area. And 4 is the most dangerous. A lot of people think that 4 is too small of a number to really indicate that something is dangerous, but if we had this scale go from 0 to 100, the more numbers we've got, the more decisions you have to make. Remember, this is the kind of information we need to tell, like, can I touch this? And if, like, it's 0 to 4, then maybe a 2, 3, and 4 I should maybe not touch. Maybe I should go get some more information about, but a 0 and a 1, I can. If we have a 100-point scale, where in that scale would I stop touching it? Is 50 what's dangerous? Is 10? Is 20? Like, there's too many decisions to make. What's the difference between a 99 and a 100? Is the 100 the only thing that'll kill me, or is the 99 dangerous enough that I shouldn't touch it? It could kill me. If you have too many numbers, you start having to make more decisions, take more time to think things through, and that is the opposite of what we want with these labels. So we have a nice short system, and those numbers tell us how dangerous these chemicals are in these specific areas. Now, before we talk specifically about what each of these colors means, in your packet, you don't have these nice colors printed out the way that I have them here on the screen. So I would like for you to color code these 3 colored sections so that when you look back on this later, you know exactly where these colors are, because they're always going to be in the same order, and they do use this color to help us understand some of the types of risk that we have, the types of hazards that we have. But as long as you kind of understand where each of them are, the numbers are really what tell us how dangerous things are. And so we don't need the colored spots to help us all the time. We can use these NFPA diamonds without it, but it does help if you can see color. But even if you're colorblind, these hazards are labeled with those numbers, and you can always figure out what hazards there are and how big of a risk you've got touching substances. So let's talk about what these colors actually represent, what kinds of hazards we need to be aware of. Red, as you might be able to guess, represents fire hazard. And before you go writing down all of this stuff over here, you do not have to know this stuff. You don't have to write it down. I've put this here just so that you know what these numbers mean. I think that it's useful to kind of understand what the rules and kind of regulations are for what numbers are which. But all you're responsible for knowing is that red represents fire hazard, also that red is this top section of the diamond, and that a big number there means that it's going to burn really easily and be really dangerous in respect to fires, and a 0 means that it's not dangerous with respect to fires at all. So, red represents fire hazard, and as these numbers over at the left-hand side on my diagram tell us, a substance that has a 0 in that red space will not burn. No matter how hard you try, it will not burn. No burning risk, all the way up to something that will burn below 73 degrees. If you're thinking to yourself that 200 and 100 are nice even numbers, why would they suddenly just move to 73 degrees? Well, 73 degrees is generally pretty close to room temperature. So a 4 in that red space tells us that that substance will auto-ignite, will burn all on its own if you just leave it out and let it come to room temperature. That's definitely something you need to know. So that 4 in the red tells us it's the most dangerous because it will light and ignite the most easily. This blue hazard that we have here represents how dangerous a substance is to your health. Human contact. Can you touch it with your skin? What happens if it gets in your eyes, lungs, stomach? And a 0 in that blue space means it's just normal material, should be safe as long as you follow normal safety precautions, all the way up to a 4 being deadly. You do not touch or open any containers that have a 4 in that blue space. It's not worth it. You'd go look at the SDS first, or ask your teacher or someone that is responsible for that material before you ever go near something with that 4 in the blue space. Yellow represents reactivity, and this covers basically everything else other than fire and humans. This tells us how a substance will react and act with other substances. So 0 means it's stable, it's generally not going to be reacting with other stuff, all the way up to 4, meaning it will react and may detonate, meaning explode. So this is very important stuff to know. Now that white space that we have down at the bottom is sometimes left blank, and even if it isn't blank, you're not going to see a number in it. The white space is for any other special hazards or other concerns, and sometimes they use pictures in that space to help display the issue or the hazard that anyone can understand in any language, even if they aren't familiar with the rest of those colors and what they represent. So You can see a couple of examples of codes for oxidizers and acids that we might put down there, but also some pictures. A W with a line through it represents keep it away from water. That radioactive symbol, of course, you might be familiar with, and there's lots of other pictograms that could go in that space. And like they say, a picture's worth 1,000 words. So using one of these pictures can help everyone, no matter what their chemistry background is, understand the dangers that go with these substances. Now, to finish off this page, we're going to quickly touch on lab equipment, and hopefully you had the chance to do our lab equipment stations to have some hands-on experience with them. If you didn't, then let's get you at least looking at some of these pictures and examples of this equipment real life in class before we get to a lab. But what we need to write down in our notes and remember in general is that there are 3 basic types of lab equipment. Reaction equipment, even though it says reaction, it's not only for chemical reactions. It's really for holding chemicals, whether it's a single chemical or more than one chemical that are actively reacting. It's basically just a fancy chemistry cup. And beakers almost look like cups even, and then flasks are also a classic example of reaction glassware. Measurement, of course, is equipment made for measuring, but we can't define a word with itself. So measurement, what we can say is quantifies amounts, but it's a number to how much stuff we have, how big, how small, how hot, how cold. Graduated cylinders are going to be the main way that we measure volume. Scales are going to be how we measure mass. Thermometers we use to measure temperature, that kind of stuff. And then last but not least, transfer equipment is all about moving chemicals around. So this isn't someplace you're going to store the chemicals long term, like the reaction glassware, the reaction equipment. But this is just for temporary, squeeze up a little bit of stuff into a pipette, squeeze it out into another container. So it's just about moving those chemicals from place to place. Pipettes we use most often with liquids, scupulas we use for solids. So that's it for page 2. Hopefully that helps, and if you have any questions, let me know.